All right, so this is objective 3.1D, point 2, day 2. We're still working on solving rational inequalities in one variable, and our objective remains the same. We are solving and choosing the sign chart method that helps us to determine the solution set. And we're writing our solution set in interval notation. So that hasn't changed. The problems are just a little more complex. And I think I just won't walk around today. Okay. Are you ready? Here we go. So we're going to start with the process that we can follow, and we will be able to get through each problem. Step 1 is different than what we're used to seeing. The first thing we're going to do is we're going to rewrite the inequality with a 0 on the right side. Because what we want to do is make it look like the ones we did yesterday and the day before. Okay? We're going to find the common denominator and rewrite the left side so that it is a single fraction. And this is where the work will come in for you guys, practicing math skills. We've done it before. Every time we do it, it gets a little easier, so don't stress about it. Then we're back to where we were yesterday, where we'll determine if the solution set should contain the 0 and if it should contain negative or positive intervals. What kind of numbers will we be looking for? Then, of course, if necessary, we will factor the numerator and the denominator. Once we do that, we will find the zeros and plot them on the number line. Then, identify the restrictions. And there might only be one, or there might be multiple. We will deny them on the number line. They are not part of our solution. We will use our sign chart to identify the negative and positive intervals. And then we will write our solution interval notation, watching out for placement of when we should use a parenthesis or when we should use brackets. Sometimes that'll be a combination. Okay? So the first two steps are new, but everything else is what we already know how to do when it comes to solving rational inequalities. What you'll notice with all three of the problems you've been presented with today is it doesn't have an x in the numerator. The x is only in the denominator. Okay? And it doesn't have a 0 on one side of the inequality. So what we're going to do is we're going to take these problems and we're going to rewrite them so they look more familiar. To do that, step 1 is we're going to make 0 live over here on the right side by subtracting 2 and pushing it to that side. So I'm just going to rewrite it up here. So we're going to have 6x minus 2 is greater than 0. I think I'm going to switch to black pen because my black pen is representing my pencil, okay? Okay. All right. So that was step 1. So it's starting to look a little better, but not quite. Step 2 is to find the common denominator. So I'm coming down below the line, and I'm going to take 6 over x minus 2 over 1, and I'm going to start creating fractions. And what I want to do is develop a single fraction out of these two. To do that, they have to have the same denominator. So what is our common denominator? It's x. And 1. But 1 times x is just x, right? You just multiply them. So it's 1x. So what we have to do is I'm grabbing a color here. We're going to multiply the second fraction times x over x. Because we're creating that common denominator of step 2 is greater than 0. and we're going to rewrite it now as a single fraction. They both have an x in the denominator. So I'm going to write it as a single fraction. And I'm going to just take my numerators and put them together. So 6 minus 2x over x equals 0. And now we are back in familiar territory, correct? Familiar. So you just have to do a little bit of manipulation. Take your power that you have and change this problem so that it looks like something you can manage in your sleep. Almost by now. Okay, so step 3 is to factor. But I got to tell you, oh no, that's not. We're on step 3, determine what kind of numbers we want, right? So what kind of numbers are we looking for if we're looking for greater than 0? We are looking for positives. So we want positive numbers. So I'm going to grab my highlighter. I'm going to focus on that. I'm going to make that stand out so I remember that. Sorry, I forgot that. Now, the next step says we're going to factor. But I got to say, these are both linear. This is not a quadratic polynomial. It's a linear polynomial. So I'm going to show you, please don't write this down, but please just engage in what I'm talking about here, that I don't need to factor my numerator, even though there's a common factor there. So let's say I do factor. I would factor out a 2. Will you agree? Times 3 minus x equals 0. So to solve that, I would divide the 2 off, which doesn't change anything, right? And then I'm just going to be lazy and add x to the other side, and I get x equals 3. But watch what happens if I had just left it alone and hadn't factored it. I'll add 2x, just so I don't have to deal with the negative. 6 equals 2x. Divide the 2, which I did earlier, and I get x equals 3. So I didn't have to factor that to solve it because it's linear. It's to the first power on your x, so you don't have to factor those if you don't want. What do you want to do as a class? Shall we factor or shall we just solve? Solve it. All right, so let's find our zeros. So let's go do that. Ready? So here we go, zeros. We're going to say 6 minus 2x equals 0, and x equals 0, because we're finding our zeros. This is step 4. Yes? It's 5? 5 is find the zeros? 4 is factor. Oh, we can skip that. Okay, so this is step 5. So we get 6 equals 2x, and x equals 3. And if you want me to not skip steps, talk to me now. Hey, what's up? He's right here. Trying to raise your hand. Okay, so let's take a look at our 2 zeros. In our numerator, 0 is 3, and our denominator 0 is 0, and we are going to deny that. So I'm picking up my red pen and I'm saying no to 0. I'm going to put a red box around it and a big R to say restrict, because I don't want that guy. He makes my denominator equal 0, which creates an illegal action. Illegal. All right. So now that we've identified our zeros, we're going to plot them on our number line, and you guys can still work down. I'm going to work horizontally. So I'm going to take my, back to pencil. 6 minus 2x and x. I'm going to take my 2 polynomials, and I'm going to stack them, and I'm going to create my number line. So we're going to use a sign chart. So we're going to plot our zeros, 0 and 3. And I'm going to grab my red pen, and I'm going to deny that 0, because that's a restriction. He's on restriction. He can't play today. And then I'm going to ask myself, do I want to include the 3, which is my other 0? I don't, right? I just want positives. So I'm going to go ahead and put brackets or parentheses on that as well, but I'm not going to red parentheses because it's not a restriction, it's just a 0. Okay, so now I'm picking up my highlighter again, and my focus is right here on this thing that we don't typically see. It's a 6 minus 2x. And we talked about this a little bit yesterday. When our x is negative or being subtracted, what happens? Do you remember? Yeah, this whole line that we're about to create is going to flip. Okay? So I'm going to make myself a little note with my pencil here that the negative or the minus x, so I'm just going to say the negative x, do you guys understand that? Reverses the sign chart. Or I'm just going to say the sign. And it's highlighted. So we've highlighted the signs that will reverse. Okay. So I still have my pencil here. And what's my 0 for 6 minus 2x? 3. All right. And what's my 0 for x? Obviously. All right. So I've got my intervals now. I've got 3 sections in my number line. I have interval 1, 2, and 3. So going back up here, because that's a minus 2x, I'm just going to prove it to you one more time, and then you can trust it a little bit more. If I pick a number like negative 1, yes? 6 minus 2 times negative 1, I'm just plugging it in. That's 6 plus 2, which is positive 8. See that? Usually we put negatives to the left of 0. Let's pick 1. 1 lives in interval 2. So 6 minus 2 times 1, that's 4. That's positive. If I pick 4, 6 minus 2 times 4, that's 6 minus 8. That's negative. Okay? So again, when we have that minus on the x, in front of the x, it reverses our whole number line. It switches the negatives to the positive side and the positives to the negative side. But of course, we don't have to worry about that in our denominator, or this bottom one. To the left of 0, a negative 1 is a negative 1, and a positive 1 is a positive 1, and a positive 4 is a positive 4, and there you go. Okay, so now that we've done all that, let's find out what kind of interval we have here. Positive divided by negative is negative, positive, and negative. Okay, so now I'm going to grab my highlighter. And I'm going to go back and look at my highlighted section. I wanted positive intervals. Well, the only positive interval was right here, between 0 and 3. So my solution in interval notation would be from 0 to 3, non-inclusive. And then just because we have a little room, let's do a little check. Let's pick a number from our section, our interval, and plug it into our original. 6, okay, you want to pick 2? 6 over 2 is greater than 2. Yeah, 3 is greater than 2. Check, that's true. That is totally true. Okay, so what I'm going to do is I'm going to clear this page out, and I'm going to show you the graph of this just so that you can see if we were to put this in a graphing calculator. All right, so here's your zeros. See how you're denied that right there. And then there's your 3. And to the left of 0, what kind of numbers did we get up? Negative. Between 0 and 3, what kind of numbers? Positive. And after 3, negative. And so our solution would be 0 to 3, just like we came up with. Right? Okay. Any questions about that? Because that's the basic idea for the next 2 problems that we're going to do. They're just slightly more challenging. So if you have any questions, now's the time to ask. Anybody? Step up, be brave, be squeaky. Okay. Here we go. Number 2. Process again. Let's go a little quicker this time. Get your pencil. First thing we're going to do is what? Well, aren't we taking the negative 3 to that side? Because we want a 0 on the right side. So we get 5 over x minus 1 minus 3 is less than or equal to 0 because we're taking that negative 3 to the other side. Okay? And now we're going to find our common denominator. So we're going to write 5 over x minus 1 minus 3 over 1, and we're going to stop there. We're going to think, what is our common denominator? 1 and x minus 1, not x. That's x minus 1. Because if x is 5, this is 4. So I need the minus 1. So my common denominator is 1 and x minus 1. So if I multiply this times 1, it won't change anything. But I'm going to go ahead and multiply this side times x minus 1 over x minus 1 is less than, or equal to 0. I'll grab my highlighter, and I'm going to pay attention to the fact that that is a negative 3, because I'm about to rewrite this. So my new denominator, my single fraction, my new denominator is what? Denominator, people. X minus 1. Now let's go to our numerator. We have a 5, yes? Now we're going to distribute our negative 3 to our x. And we're going to distribute our negative 3 to our negative 1, positive 3. You with me? Okay. Now, my numerator is not as simple as it should be. I need to combine my 5 and 3. So I'm going to ask you what you prefer. Do you want to write this as 8 minus 3x or negative 3x plus 8? You pick. 8 minus 3x. Okay. So we're going to go 8 minus 3x over x minus 1 is less than or equal to 0. So we have now done step 2. We wrote it as a single fraction. So you can see where the complication lies. Yes? Okay. Just practice that and be careful. Now let's choose the kind of numbers we're looking for this time. Less than, negative, and 0 are less than or equal to 0. So I'm going to grab my highlighter and I'm going to focus on that. I'm going to erase a little bit so I have space. You guys all have this second step here. Can I erase? Okay. So now we're going to find our zeros. You ready? 8 minus 3x equals 0 and x minus 1 equals 0. Ah, my leg's asleep. So I'll add 3x, and I get 8 equals 3x. I'll divide the 3. So x equals 8/3. Sorry for those of you in the back. I know, but Sarah's not. Can you see, Sarah? Okay. All right. And then our other 0 would be 1. But actually, it won't be. Because what does that create? A restriction, because that's our denominator. Now, do we want our other 0 this time? Yes. So I'm going to put a little box around that guy. All right. So back to my pencil. I'm now going to create my number line by stacking my two binomials, 8 minus 3x and x minus 1, and drawing my number line and plotting my zeros, which were 1 and 8/3. I did a good job, right? 1 is smaller than 8/3. Yes, okay. And now I'm going to deny my restriction. Sorry, buddy. Denied. And then my 8/3 I want to include, so I'm going to go ahead and put brackets because I want it. Create 0. I want that. Okay. I'm switching again. Highlighter. Because of this negative on my x, do you see it? I'm going to highlight that whole number line right there that I'm about to create. Yes, I'm going to make my little sign right here that says reverse, just to remind myself that I'm reversing my signs right here. I'm reversing that. Okay? All right. So my 0 for my numerator was 8/3. And since I'm reversing, oh, my 0 for my denominator is there. So I got my dotted lines in. I got my intervals all spaced out. So to the right of 0, I'm sorry, to the left of 0, we go positive, and to the right we go negative because we're in reverse land. But in my denominator, just regular. Left is negative, right is positive. There we go. Okay, so now we multiply. No, we divide. Positive divided by negative, positive, negative. Okay, then we grab our highlighter and we go, we want negative and zeros. So we want this section of our number line and this section of our number line. And we find our solution. From negative, and that's the wrong color. From negative infinity, that's not an infinity. What's going on with my brain? Negative infinity to 1, non-inclusive, union with 8/3 to infinity. Oh yes, 8/3 inclusive, thank you. Inclusive 8/3 to infinity. So we could check by plugging numbers in. We could. So let's plug in a 0, because 0 is easy to plug in, right? So 5 over 1 minus 0 is less than or equal to, wait a second, no, 3. But it's 0 minus 1, thank you. I was having a brain fart. That's not good. I probably shouldn't have said that on the video. Oops. Okay, so that would be 5 over negative 1. Is that less than or equal to 3? Yep. And then if I plug in like a number like maybe 6, 6 would be over here. I think 6 will be good. So if we plug in a 6, 5 over 6 minus 1 is less than or equal to 3. That's 5 over 5. And that's 1. 1 is less than or equal to 3. So that worked. So the numbers that we chose worked well. Anything before I erase? I'm going to bring the graph in. You guys good? Any questions? Okay, I'm trying really hard to make this as easy as possible. So here's our graph. So you can see our zeros, 1 and 8/3. And to the left of 1, our answers were. Between our zeros, the answers were. And on the outside of this 0, it went back. And those were the sections we chose. So we did that right, too. Impressive. You're impressing me. Okay. Last problem. Remember that I asked you to change this to a 7 over x squared minus 9. And I got to tell you, this one's not as fun. I'm sorry. We're going to have to start factoring. Cool. Okay, so first thing we do, we have to subtract the 1 to the other side. So we have 7 over x squared minus 9 minus 1 is greater than 0. Okay. So we move now to step 2 so that we can create common denominators. So we're going to go 7 over x squared minus 9 minus 1 over 1. And you tell me, what's my common denominator? X squared minus 9 over x squared minus 9. If I give a 1 to that one, won't change anything. But now they have the same denominators. Is greater than 0. Okay, I'm grabbing my highlighter because I'm focused on the fact that I'm going to be distributing a negative 1 here. Well, let me see if I can get this a really skinny little, there we go. I'm going to distribute that guy. Oh, you guys can't see the yellow very good. Oh, you should have told me. Oh, man. Okay, now you're being just as a brat. So there you go. Can't see the green very good either. I'll switch to red from now on, or orange. Okay, thank you. It looks great on my screen. I don't know what you guys are crying about. Okay. All right. So let's keep working. So we have 7. Oh, our denominator. Let's do that first. X squared minus 9. Same denominator. And we're going to distribute. Negative 1 times x squared is negative x squared. Negative 1 times negative 9 is positive 9. Is greater than 0. All right. So in our numerator, choices. Because we have to do 7 plus 9. Do we want 16 minus x squared or negative x squared plus 16? I think that's probably a good choice. More of you said that, so we're going to go with that. 16 minus x squared over x squared minus 9 is greater than 0. So now we have a single fraction and quadratic work to do. Let's choose what kind of numbers we're looking for, though. Positives. We want positive numbers because they are greater than 0. I'm going to grab my highlighter. Look, you can see that one. There we go. Okay, so now we got to find our zeros. These are easily factorable. Yes, they are. Don't tell me they're not. 16 minus x squared equals 0. That factors 2. Open up your binomial pairs. It's the difference of squares. This is a perfect square. 4 times 4. X squared is a perfect square. X times x. But I want a negative x squared. So I want one negative and I want one positive. And folks, it's factored. Now we just have to solve. Yes? So 4 minus x equals 0. I think we can just add x and solve that problem. So 4 equals x. Done. Then we have 4 plus x equals 0. And I think this time I'll subtract the 4 so I don't make my x negative. So x equals negative 4. So there's our zeros from our numerator. Questions before I move on to my denominator? What? Yes, I'll switch to orange highlighter from now on. Okay. X squared minus 9 equals 0. We got to factor our denominator. Okay? Also the difference of squares. No b term. Open up your binomial pairs. Split your x squared into x and x. Shh. Split your negative 9 into negative 3 and positive 3. And I think you can see these zeros without too much math. The first 0 is 3, and the second 0 is, and then we grab our red pen and we go no to our denominators. Restriction. Okay, now we've factored that guy out. We didn't do a very good job of writing it out in factored form. Do you want me to do that? It's supposed to be 4 minus x over 4 plus x, and then x minus 3x plus 3. No, that's fine. Okay, so you ready to stack? Here we go. 4 minus x, 4 plus x, x minus 3, x plus 3, number line. Zeros. Negative 4, negative 3, 3, and 4. Right? And then grabbing our red pen, here we go. Deny your 3's and your negative 3. Nope. Here's our restrictions. But how about our 4's? Do we want them? We don't want our zeros? No, we don't. So we're not going to deny them, but we're not going to include them. Not included. Okay, back to my highlighter. I'm crazy about my highlighter. That's a negative x. Do you see it? Your first one? So I think I was highlighting this in green, but I don't know if you were seeing it. So I'm doing orange. Per your request in the back. Right? Okay, so that's a reverse of that. Okay? So let's not forget to do that. Let's go plot all our zeros. So what's our 0 for 4 minus x? 4. Okay? And 4 plus x is negative 4. X minus 3 is positive 3. And x plus 3 is negative 3. There we go. So we had all 5 intervals. That's a lot. Yuck. Okay, and then in our numerator, our first term, everything's backwards. So in reverse land, positives are on the left and negatives are on the right. And then nobody else is in that land. So negative on the left and positive on the right. Oh, this sign chart. I'm thankful for it because it's better than plugging numbers in. Okay, So in my first interval, I have 3 negatives. That means I have a negative interval. In the next interval, I have 2 negatives. That means positive. Then I have 1 negative, no negatives, 1 negative, negative. So it goes negative, positive, negative, positive, negative. There you go. And we want positive. So we want this little baby section right here and that little baby section right there. It's not very many numbers that are greater than 1. I guess, that are in fraction form. I don't know. So our solution, from negative 4 to negative 3 non-inclusive, union with 3 to 4 non-inclusive. So a really small section of our number line. So be paying really close attention to those negative x's when you're doing your sign chart. Okay, be careful when you're factoring. You only have 2, I think, like that. Austin. Are you good? You see it? Okay, one last thing I want to do is I just really quickly want to bring in the graph so that you can see this crazy wild graph. Look at that. Kind of different. Make it bigger so you can see. See it? Okay, so there are our zeros. You see them? Negative 4 and negative 3. And left of negative 4, our answers were negative. Between 4 and negative 3, they were positive. Between negative 3 and positive 3, they were all negative. Between 3 and 4, they were. And then after 4, they were. So we did a good job, again, choosing the correct answer. So nice job. Okay, so that was a long video. Bye, video. Okay, say bye, guys. Okay.